Well, hi, good morning. Thanks so much for joining me here in my shop while I continue working on this radio. Just a couple things before I get going. First one is about comments. Please read the video description before you make comments, because some of the comments that are being made are covered off in the description. I spend a fair bit of time writing video descriptions to try to help people anticipate what the video is going to be about without giving away any of the funny or interesting parts that might be in it. And I hope reading the description is a helpful thing. So please, if you're going to make comments, just read the description under the video before you do that. Number two, the burned out coil, or the burned piece of wire in this coil. I'm learning a lesson again, the same lesson I learned a few radios ago. I haven't investigated this yet, but I'm sure at this point, if we do, we'll find out this is the antenna coil, and that the burned wire is really due to some kind of charge coming through the antenna, hitting that wire and burning it out. Now, what kind of charge? Well, it could be everything from some kind of lightning effect, from an outdoor antenna that this radio may have been connected to at one point in its life, or more likely something happened inside the house between the hydro system ground wire or something of that sort, some ground wire or something. And pretty sure. Look, there's still a piece of wire on this. Aha! There it is, the piece of wire that did it. Actually, you know what that is? That's the end of a. What is that? That's the end of a clip there. Oops. Okay. Anyway, so I'm going to continue to leave that coil apparently with an open in it. And I'm going to continue to work on the radio, get all the other problems ironed out until all that I believe is left is that coil. At which point we'll find out if this radio can work at all with that coil open. You wouldn't think so. I wouldn't think so, but we're going to find out that way. So that's the approach I'm taking on this. Next round of capacitors are going to be capacitors related to the audio circuits in here, and I think we can take a guess. So this is the audio output tube. Now we can guess it's going to be this, this, and this, and this guy too. He's right on the volume control. Oh, actually, you know what? The audio is passing through this capacitor, heading from the radio side of things over to the audio side of things. So that, and that. In fact, it's interesting that they used all these molded capacitors here. Must have got a good deal from the manufacturer. A warehouse full of those, and they had to use them up on their radios. Okay, so I'm just going to proceed to change those 4 capacitors, and I think the radio was going to sound exactly the same when I'm done, but let's see. We'll see what happens. Oh, I changed my mind a little bit and want to play around with this radio just a bit before I do those capacitors. So what I've done is I switched on my signal generator. It's running at 1 megahertz, and we're just going to try to tune in the signal generator with the radio, even with the coil open. I'll use this as my broadcast coil, broadcast to the antenna, and we'll just see what it does, if anything, really. Good. There we go. My guess is now, after my guess is I've done a number of radios similar to this one with the same coil popped open due to some kind of incident, and I never became aware of it, never became suspicious of it, because I know that I've done a couple of radios similar to this over the years where it seemed like no matter how hard I tried, they just wouldn't receive well. And I'll bet you it was that open coil. You know, if it is popped open from some kind of event, that could happen inside the coil where you'd never see it. You'd only find it by testing. It's just amazing that I managed to spot this one, really. And I could be wrong about all that anyway. See, the curious thing is it's receiving a station right now. Okay, let's go up to a million. Whoops, let's go up to 1,000,000 here. sign of the signal generator, but maybe the signal's, oh, it's very low. There we are. Now we can hear it. Wow. Did you hear that? It's receiving really well. Kind of odd, eh? How can that be the case? Maybe I'm wrong about this wire. Maybe I'm wrong about it. And what if we stick 455 onto this guy? Let's try that for fun. 455 would be the IF frequency in the radio. Yeah, just so this will give us a notion as to how well tuned the IF is in the radio. Okay, we'll just set that there. I'm just going to vary the frequency on the signal generator. We'll just listen to the tone vary. Oh, it's pretty well done. I'd have to guess it's at 450 based on listening to it. That didn't seem wonky or anything, but you can't tell by doing that if maybe one of the transformers is tuned up to 455, the other one's 450 for some reason. It's not really going to be apparent doing that. And also, I don't know objectively if that was strong or weak. I don't know how strong this was, so I don't know a lot other than some sound came out of the radio, which is kind of encouraging. And the sound quality seems fine. Maybe there's some volume loss in here, but I hardly had this turned up. So once again, a bunch of bad looking capacitors. Doesn't seem like the end of the world, does it? Okay, let's get rid of them. We'll test them all. I'll take them all out. We'll test them all at once and see what we got after I do them all. Okay, away I go. And also, before I change them out, I thought I'd just take a moment and just identify what each of these capacitors is doing, just so I'm a little more certain of what I'm up to. So I don't know if you can see it in the camera, but I've numbered them 2, 1, 2, 3, and number 4. Turns out number 1 is the volume control blocker. It's right on the slider here, so that's what that guy's doing. Number 2, this one is basically from the plate of the output tube to the B minus. What the purpose of this one is, I'm not sure, but I think maybe it's just to get rid of any RF that's made it all the way through the radio to the output tube. I'm not sure what that's for. And then number 3 here is the grid blocker to the output tube. So that's running from the plate of the detector tube, the triode part, over to the... So this is a pretty important guy. If he's leaky, then the grid on the output tube can run too positive. And without knowing it, you can be cooking your output tube or something like that. So this is a critical one for a leak. If there's a leak here, it's critical. Same thing with this one, sort of, but this one's really, really important to check. Or replace. I mean, we're going to replace it. Number 4 here, this is why it's a good thing I did this. Turns out number 4 is right across the power line. So the one I did up here was B minus to chassis. That's this one here. This one's right across the power line. I've got some special capacitors to replace that. So I heard it said, and I never really looked into this, and I don't know if it's really true or not, but one of the purposes of this capacitor is to enable the antenna system to work better. Since there's no ground on the radio, nobody's driving a ground rod in the ground hooking up to this radio. I hope not anyway. The capacitor gives the radio some attachment to the power system. It gives the radio part some attachment to the, hydroelectric power system. Actually, in Ontario we could call it a nucleoelectric power system because it's half nuclear. So, but I don't know if that's really the case. It's across the power line, and surely if this guy developed a short, that would be kind of exciting. So I'm going to put a shortless capacitor in there. Okay, let's carry on. Okay, let's give those capacitors I removed a test here. Come on over the other side of my shop. Now, if you're a new viewer, you might be saying, well, why you bother testing all these old capacitors? And I do it to keep myself honest. So I know for sure that what I think is true is true. That's why I do all this. I think, you know, the main driver in me doing all this work is curiosity. That's what drives me, curiosity. Okay, so this is number 2. So number 2 with a great big crack in the shell there. Number 2 was the plate to B minus capacitor, whose job it is, I don't really understand exactly for sure what it is. Here we go. Yeah, I shouldn't be doing that. Okay, let's leave it over here. Here we go. 25 volts, 50 volts actually. 50 volts for real. What will it do? Make sure this is correct, yes. That popped open pretty good. That's pretty impressive. That's really impressive. Okay, let's hit it with 150 volts. That's much less impressive, so it's not popping open there. Usually, you don't see a dramatic difference between those two tests like that. Great big crack in the shell. You know, one good shove with the screwdriver and this thing will open right up. Maybe we'll do that after. We'll take a look at what's inside. Okay, next one is number 1. Number 1, volume blocker. Okay, so this guy has an important job to do. Keeping DC from the detector, basically the ADC voltage, from getting further into the audio circuits. It's supposed to stop at this guy. Let the audio through and stop the DC. Right on the volume control. 50 volts. Can he do it? Yeah, just like the last one. But what about 150 volts? Wow. Okay, that's a beauty. This capacitor is rated for 600 volts, so let's keep going. So when I start seeing something like this, where I'm getting an old capacitor to apparently show no sign of leakage at a high voltage, I start thinking there's something else going on here. And that is the connection, through the connection of the lead to the foil may be open. Now this radio is working, so I can't imagine how this could be open and no audio would make it through. But that's the kind of thing I start thinking. Is this one cracked open too on the end? So this one is not cracked. Not cracked open. I mean, visually it looks okay. Let's give it 350. So that's really, really impressive. So now I'm thinking, okay, I don't have this connected. Let me take one off and we'll do the same test now. There's no capacitor there. So the thing to notice is how fast this operated. This operated like a bullet. If I put this back on, we'll see that the eye is just a little slower. That's the capacitor charging. This guy comes out like new. Huh. Who'd have thought, hey? Now the last one. 1, 2, wait a minute, there's supposed to be 4 here. What have I done? Did I do? Here it is. Here it is. Here it is. Let's do the last of these solar guys. Number 3. Capacitor number 3 is the very, very important grid blocker on the output tube. So again, this guy's job is to keep plate voltage from getting to the grid of the output tube while passing the audio signal. He's got a crack. It's cracked open completely here. The seal is, the seam is cracked open here. I was thinking about this sliding covers and the crack, and I think what this shows is one of the components in the plastic cover here, the molded plastic part. One of the components is vaporizing off, and over the years, with that component missing, this has gotten smaller, and that's what's causing the cracking and also causing the sleeve to come so loose. That's my theory. 50 volts on the grid blocker. Another one that looks pretty good. Look at that. Okay, let's hit him. 250. So it didn't quite open that time. Well, it did. Wow. Okay, so contrary to what I would imagine, a capacitor with a big crack in the end of it there. Still tests really good. That's why I test these capacitors, because the assumption that they're all bad, well, that's a good assumption, but it is just an assumption. So I just like to verify these things. So next thing to verify is that the radio is still working. So you can see I put in 3 tubular ones and then this funny looking capacitor here. So these are special capacitors that you use in situations where a short circuit might be something you never want to have happen. I guess I would put it that way. So this one is installed right across the line where that other one was. I think it was this one. So I don't know exactly what's going on inside it that makes it so much better, but supposedly it is. So this should never ever short. What are we left with now? Just two wax capacitors in the RF part of the radio. Oh my gosh. There must be another one in here somewhere. Maybe not. Okay, let's give it a go. Switch is off. Plug is in. The mysterious radio that works despite an open coil. Power on. Gotta find myself a new light bulb for this guy. Hello, radio. Tubes are lit. I just got. Oh man, I'm impatient. Volume about the same. And I can't imagine the reception would be any different, but I still got my signal generator running. So let's see. I'll just dial up first. Change this. Read the number there. Let's just roll through the IF. Oh, let's do 10 over here. Oh, there it is already. Pretty darn close. If it's not right on, it's really close to 455. Oh. What was that? Oh, okay. Well, the story has changed dramatically here. There's something way out of whack on this radio. So just at a glance, it looks like one IF transformer is tuned up to 455 and the other one's tuned up to... Well, I'm not sure how to read that. Something wrong there, though. Definitely. Huh. Okay, that's surprising. I was not expecting that. Now, the radio is actually tuned to 1 million cycles per second, so let's go there. Fairly strong signal. What was all that nonsense? Holy smokes. So I'm hitting it with a strong signal, but it is just through an induction coil here. Not the strongest signal. That's not an unrealistic signal level. Let's just roll through that again. 1, 2. Ooh, a big long 2 with a super spot right there. Another one. Can't go any lower here. What is that? Some odd stuff coming through here. Okay, one IF to other IF. And now we'll go up to... Oh my gosh, this radio's full of junk. So what can be happening there is I'm putting in another signal into the mixer tube. The mixer tube, you might think of it as just another local oscillator signal coming in. Of course, the tube doesn't think of anything, does it? But it may react to it as and just mix other signals with it. So as I tune my signal generator, it's not much different than tuning the radio. And as I come across other signals that are mixing and coming out at 455, we hear them going through the radio. So what that really means, I don't know. But these very strong weirdnesses, where did they go? Strong weirdnesses. Yeah, wow. He's messed up pretty good. So we only have 3 more capacitors to do. 2 more capacitors to do. Then all the obviously, potentially bad capacitors are out and gone. And they are in the radio circuits up here. I think I should just carry on and get rid of those. That's a good idea. And see if this nonsense changes. Oops, I made a little video error there and wasn't recording when I thought it was. So I'm going to repeat what I think I just did. And that's just to test this resistor on camera. There it is, 350 instead of 270. Looking for a higher bias. And then this is a capacitor. How good can this one be? So I'm really surprised that those last few molded ones I tested, they came out good. I was not expecting that at all. And this one, well, yeah. Let's see what it does. It looks not too bad. Doesn't usually mean a lot. Okay, ready. Leakage test. Watch the eye. Slam shut. Yeah, it's really indicating very a strong leak or a lot of leak. A lot of leak. A lot of leak. So good that guy's coming out. Usually, you know, the molded capacitors, usually these guys are spotted as a really bad actors, but this one's turned out to be not so bad. Okay, so I'm going to replace this guy in here, and then we'll deal with that one afterwards. There we go. Good. There we go. Oh, it's a little warm. Now the next one. Number 5. Number 5. Let me find out what that guy was doing here. So if we just take a look here at the capacitors I'm working on, this is the one I just put in the radio. And that's the resistor bypassing it. That's the, if we just follow this line up, we'll see that it goes to the suppressor grid and to the cathode here. So this is a cathode resistor, cathode bias resistor. And you can tell from the size of it. A small resistor like that is almost always cathode bias resistor. Not always. And then the capacitor is the bypass capacitor around it. Make sure the signal doesn't pass through the resistor, or the result of that is apparent reduction in the gain of this tube. You just won't get as much out of it if you let the signal pass through here. You can always look for one of these resistors on the output tube. So we go to cathode, follow it back, and sure enough there's a small resistor, 240 ohm resistor, and this guy's bypass capacitor is this big one here, 10 microfarads as compared to this thing, 0.05. This is hundreds of times bigger, 100 times bigger, something like that. He's got a harder job to do. This is a harder working tube. There's more happening in the cathode circuit. So he's got to be bigger to get rid of all that audio stuff that might go through this resistor. Now this guy over here, he's not doing audio stuff. He's doing RF stuff, so he can be small. So that's the deal with that resistor, which I've got installed here now. The other one I've taken out. It's this one here, 0.05, pretty sure. Yep, 0.05 on the capacitor. And what's it doing? B minus. So it's tying B minus to this line RF wise. And this is the, yeah, so this is what it's doing is it's just kind of RF grounding the bottom of the transformer here to the B minus line. At the same time, they got to sneak some ABC voltage in here, some DC voltage. So AC grounded to the B minus line, but DC wise not grounded, and they can float a few volts negative in here to operate the grids. If this guy's leaking, it would kind of ruin the effect on this side, because this is a high impedance circuit. Look, a megohm there, 2.2 megohms here, and the grids of course are pretty much infinite resistance. They're not really going anywhere. So it wouldn't take too much of a leak to drain the charge out of this part of the circuit. A little leak here might have a bigger effect than we might imagine. So I cut that guy out. I've already cut him out. And we'll stick him on the tester here. See what happens. Here he is. Looks okay. So, you know, by my thinking, this is a pretty important capacitor if it's leaky. $50 volts. What do you do? She's shot. So, again, you know, so what about this thing as a capacitor? I mean, obviously it's working as a resistor these days, but as a capacitor, I don't know what to say because I can't really test them properly when they're leaky like that. So is it like a capacitor, is it like this, a capacitor with a resistor in parallel with it? And what would that do? I don't know. Okay, so we're going to put in the new capacitor there. Okay, I think we're ready to operate this radio again and see if there's any changes in the way it was behaving. Just going to leave it like this. Give it the juice. There we go. So just a reminder for those of you who are new to my videos, I'm not really trying to do teaching videos here. It's not my intention. I don't have a particular message to deliver. Occasionally I do, in fact. But that's not really my purpose here. I'm just trying to fix a radio, and I'm inviting you along to watch me do it. I don't know everything. I don't get everything right. Apparently my soldering skills aren't the greatest in the world either. But nevertheless, I invite you to come along and see what I'm doing. What you do is really your choice and your business and your shop, your radios and your life. So, well, it's making some sound. Let's fool around with that signal generator again. And let's see what kind of weirdnesses go on here. So the radio is still tuned to 1 megahertz. The antenna's the antenna or the coil from my signal generator still hanging there. Okay, let's go right to 1,000,000 here and see what happens. Well, the bandwidth is that big. It's that big. That's because I must be pumping too high a signal in here. Let's give them something a little more reasonable. So that's the end of my run here. Yeah, I think I was just overloading the radio before. Okay, I don't think that's a problem. Now we're gonna let's overload the radio again and see what kind of nonsense comes out of it. Let's try it with let's really give it a. So I'm blasting it with a ridiculously strong signal here, and that's the fact of the matter. It can only go down to about here. We'll go up. So there was a little something there, but not much. Now, if the local oscillator is running above the tuned frequency, then the local oscillator is at 1455. And if I can get up another 455 above that, which would be around 1.9 megahertz. We'll see if the image comes through on this. 1.9, can I get there? Yeah, I think so. There it is. So what that means is with this radio, if you were listening to where it's tuned right now, 1 million hertz, 1,000 kilohertz, and there was another signal at this frequency, this radio would pick it up and would come out the speaker. And you might think you're tuning around, well, you are. You're tuning two frequencies. Basically, the radio is always tuning in two spots, and one of them it tries to suppress. Maybe that's the best way to say. So I'm looking at the one that's supposed to be suppressed. It's also out of band. So in the early days, what would be up here is maybe some police stuff or something like that. But AM radio, the powerful broadcast stations would not exist up at this frequency, so you wouldn't get that kind of thing happening. But if this whole situation with the image occurs lower in the band, there's a chance there's a broadcast station at the image frequency and you're going to hear it. Okay, great speech there, Jim. What are we going to do next? So it's aligning the radios coming soon and dealing with this mysterious, not so mysterious, non-mysterious, the open coil. The thing that's mysterious is the radio seems to work. So I'm going to lay it down here. I'm going to give it a good go. Just see what it does. I'm going to do this just like this. Wow, it turned up a little high. Now just once again, for those of you who are really new at these kinds of radios, look, I'm grabbing onto these knobs here, the chassis right out here. This radio has a danger, it's a non-polarized plug, but in my shop, this is plugged into an isolation transformer. So the chance of me getting a shock doing this is actually very, very low. But in your shop, unless you've done the right things, once this chassis is exposed on a 5-tube radio, you've got something you've got to know about. You've got to read up on hot chassis problems. Okay? So let me carry on. That was the end of that speech. Many of you have been watching me for years, so I'm really not talking to you at all. I'm talking to you who are new to this. Are we going to get anybody? Yep. So there's some directionality in the antenna. Is that coil really open? So my options here, I think we should fiddle with the coil next. Before I was going to think about, why don't we align the radio and see what it's doing? Well, it's already doing something, so I don't need to do that. Why don't we fiddle with that coil next video? Coil is the next video, and then alignment. So great. Thanks a lot for watching. And what's with that terrible hummy sound? It's not very audible without the cabinet on the radio, but quite a bit of humming going on there. I still haven't tested the tubes in this radio or anything. Maybe we should do that next too. Okay, again, thanks for watching, and I'll see you on the next video.